Okay. Hi all, good evening. I'm Sreekanth. I work with Allstate Roadside Services. I'm very proud to be part of this 3A event. Here I will be presenting a case study how AI is helping like ARS to provide like better customer service with lower cost. First, let me introduce like what is ARS roadside services. So roadside services are like roadside assistance program is a 24/7 emergency support provided in the event of like any medical or electrical breakdown and are like the traffic accident of a particular vehicle. Allstate Roadside offers fast, trackable, and reliable roadside services. Whether you need a tow, jump start, help with a flat tire, or lockout assistance and fuel delivery, help is available 24/7 right from your phone, whether you have a gas or like electric car. And also, ARS has widespread coverage across USA and Canada, all the regions, all the markets and zip codes. So in case of emergency, customer can request the service by calling our 24/7 customer care service or like through the mobile app or through our website, which is again chatbot enabled AI engine where customers can interact with our chatbot and then request for a rescue. And ARS has executed the contracts with many local providers who are going to support these services across USA and Canada, all regions, markets, and zip code. Each provider has his own coverage area. For every rescue, there might be like more than one eligible provider to support the rescue. When any customer requests the service from any location, we generally call it as like a disablement location. Our rule-based AI engine assigns a rescue to the providers by considering like the important metrics of the providers. One is what is like the ATA or like ETA for the rescue, and severity or like a cost per rescue, and the prior ratings for the providers. So based on these metrics, our rule-based MCDM engine, MCDM is nothing but multi-criteria decision making, which is an optimization engine, ranks the provider, and our system like requests the providers in the ranked manner. If none of the eligible providers accept the rescue, ARS tries to contact the nearest Jeep or like market code. We generally call it as like in-network out of coverage providers or out of network providers. Out of network providers are the ones who do not have any contractual agreements with us. In all these cases, either it is out of network or like in network out of coverage rescues, so they come with high severity and larger ETA, or like the higher ETA. So this may not be an ideal situations with respect to the customer experience or like the revenue to the firm. So ARS team has built an AI-powered engine or system called Smart Rescue Pricing or like the Smart Boost. The aim of Smart Rescue Pricing or like the Smart Boost is to make like our in-network providers to accept the rescue and reduce like out of network rescues by giving an extra amount to the in-network providers. So there are two objectives for the Smart Boost. One is like we want to reduce out of network rescues, then reduce like in-network out of coverage rescue, and then make like our first rank provider to accept the rescue or like the lower ranked provider to accept the rescue. To meet these objectives, ARS team has built two classification models, two regression models, and three clustering model. So Smart Boost is a combination of like all these seven models: two classification, two regression, and three classification. Three, sorry, two classification, three clustering models, and two regression models. Our classification models are going to predict whether it is going to be like out of network or in network. Our regression models are going to predict like what might be the severity for each and every rescue, and our clustering models are going to predict, it is going to give us a futures related to like the market characteristics or zip code characteristics or maybe the region characteristics. So any AI powered systems, it comes with its own problems because none of our models are going to have like 100% accuracy. So definitely like there should be a risk control mechanism on top of like your AI powered systems to handle like corner case scenarios. Here we have built a risk control mechanism on top of like our Smart Boost models, our Smart Boost AI powered engine to handle like corner case scenarios. Corner case scenarios, definitely it is going to have a higher effect on like a severity and then ETA. So definitely like we need to have a kind of risk control system to handle those corner case scenarios. The other reason for out of network rescues is ARS might not have enough providers in certain areas to do the rescue. So we cannot have like across like USA or like across Canada in all the regions, like we might not be having like enough providers. So definitely like you need to procure or like you need to recruit like more number of providers in certain areas. Again, you cannot recruit like the providers blindly or like the random basis. So if you are recruiting like the greater number of providers might lead to a kind of problems. The problems might be like we might not be able to assign greater number of rescues for each and every provider. If you are unable to provide volume to like our providers, so definitely it might lead to a kind of customer churn. So this problem had been addressed with an AI powered smart procurement engine, and then a smart procurement engine has four component. One is like a demand forecasting algorithm, so which predicts what is going to be like the demand in each and every area. And we have built like a geospatial modeling to identify the areas. So in the geospatial modeling, like we have created like the polygons, and each and every polygon like we are going to identify how many out of network rescues in the future, and then what is going to be like a demand in each and every polygon, and an optimization engine to suggest like the billing rate. So maybe like the providers, each and every provider might be having like a different billing rates. So definitely like you need to have an optimization engine which needs to suggest like the billing rate or contact price for each and every provider. Then finally like a classification model to identify the provider churn. So maybe like certain areas where you have the higher provider churn, so definitely that needs to be offset with like the new providers. So all these are like the inputs to like a smart procurement engine, which is going to help us, our network managers, to procure or like to recruit new providers. The benefits from these AI inventions are, so ETA or ATA for the rescue will be improved, and then it improves the customer experience. Provider loyalty will be improved, increases like our provider network, and then savings to the company by reducing out of networks, and then improves like our market share. So this is the case study, or like these are the models that we have built in ARS, which is going to help us reducing like the cost to the firm, at the same time like it improves like our customer experience.